The thrust reverser indication system gives the flight crew a visual indication of the operation and position of the thrust reverser, and the indication of faults in the thrust reverser control system. It is only given when a reverser is unlocked or fully extended deployed by displaying the REV display on the upper ICAS. A reverse amber will show when the center drive units are unlocked or the system is in transit. A green REV will show when the thrust reverser is fully extended or deployed. The position indication system consists of position switches that are mounted on each CDU, a deploy relay, ICAS computers and display, and the thrust reverser relay module. In this schematic, we're showing you two CDU position switch modules, left and right. These are also called thrust reverser logic switches. In this switch module, one of them, we have two switches, stow and unstow, not deploy and deploy. As you can see, the ICAS computer is looking for a ground to display either the amber or the green REV reverser light. Because of the reverser is not deployed and is stow, there is no path to turn on any light. Here are the conditions that will turn on a yellow or amber light on our ICAS display. If either the left or right position switch modules switches show unstowed or not deployed position, this will allow a ground to the ICAS computer to display the amber REV or reverser light on. Let's talk about what it will take to get the green reverser light on ICAS to come on. First of all, take a look at our schematic. You can see that we have to have a deploy relay energized. To get this deploy relay energized, we have to have the left thrust reverser logic switch in the deployed position to energize the coil in the relay. And as the relay closes, you can see has to go through A2 to A1 to the deploy side of the right logic switch that is located in the right CDU on the left engine. Now our circuit is complete. We have a ground that will turn on the green REV light for the left engine. A reverser isolation light is located next to the engine fuel control shutoff switches. If this light comes on, it has an associated reverser isolation message on the upper and lower ICAS displays. This light and message is caused by a disagreement of the thrust reverser PRSOV operation as it relates to the commanded reverser position. Now let's talk about thrust reverser position feedback sensors. Variable differential transducers, RVDTs. The RVDTs, or transducers, have dual feedback channels. Each thrust reverser center drive unit, CDU, has a RVDT or transducer attached. The purpose of the RVDT is to give the reverser position to the electronic engine control, EECs. In turn, the EEC commands the thrust reverser interlocks to ensure there is a correct sequencing of engine power with the relationship to the thrust reverser position. Thrust reverser interlocked actuator. The purpose is to make sure the thrust reverser does not pass through the idle detent until the thrust reversers are extended. The interlock actuators are controlled by the EEC. If the actuator fails in the retract position, the throttle will not advance past the reverser idle position. No ICAS message will appear. A left and right interlock message can appear to alert the flight crew of an interlock failure. The thrust reversers can move past the reverse idle detent before the thrust reversers are fully extended. Some maintenance tips. Thrust reverser position feedback transducers, RVDTs. These transducers or RVDTs has caused a lot of problems in the past. A lot of boarded takeoffs, return to blocks. Let's talk about a couple scenarios that are possible. You're working on the thrust reverser, including the center drive unit, or you're MCOing a thrust reverser itself. This is why it's so important that the CDU position switch module, the logic module, remember that will give you the green and amber light, and it also provides the sequence logic for the actual operation that we talked about in an earlier video. The CDU position feedback transducer, that tells the EEC what to do. Here's what happens. If one of those 4 RVDTs that we're talking about is out of rig, the engines start normally. There's no warning or any messages that anything's out of rig in the cockpit that's obvious to the flight crew. So they go ahead, start the engines, head down, get ready to take off, and then this happens. The left engine's making full power. The right engine, the EEC thinks the thrust reverser is partially open. It will not allow the engine to make full power. It doesn't want to destroy itself. We're at the EPCS page. You're seeing exactly what the EEC is seeing. We're looking at the right engine and the thrust reverser on the right side. It's showing 22 degrees. It thinks it's open. That's why the EEC is not allowing the engine to make full thrust. To rig or re-rig the RVDT, consult the Maintenance Manual 78-36-03/401, Removal and Installation. You're looking at Step 9 when MCOing a thrust reverser. Step 9 just has us confirm the thrust reverser position. It has you check A and B channels and make sure they read 0 plus or minus 2. Each center drive unit has an indicator pin when it's fully retracted. You just push on this pin. The pin aligns with the groove right there, you can see in the video, and that is your rig for 0. To rig the transducer or RVDT, you will have to remove it from the center drive unit CDU. Then turn the square drive shaft of the transducer to align the white lines on the end of the transducer itself. This is not a precision adjustment. The final adjustment will be done using the EPCS page. We've just finished an overview of the thrust reverser indication system. Your questions and comments will be appreciated. Thank you.